So I'm going to read that again. So objective 1.1a. I will be successful when I can graph a circle given standard form, and I can write the equation of a circle in standard form given radius and center. All right, so we're going to start off with some formulas that will be helpful when you're doing your assignment. The first formula is the formula to help you find the distance between 2 points. I'm going to remind you of it once. Distance is equal to the big O long square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. And I'm going to tell you that that is the last time that I will write that in that notation. I am going to give you the new updated notation that's shorter, and it is in Greek. Distance updated. This is the new updated, you need to learn it formula. Distance is equal to delta x quantity squared plus delta y quantity squared. And we're going to talk about what delta means for those of you that have never seen a delta before. So this is the capital Greek letter delta. And actually, that is improper. I should be capitalizing that. That's delta. Okay, that's the symbol for delta. It says change in. So when you see a delta, it's asking you to find the change. Find the change, which is meaning subtract 2 things. So change in x is delta x. So how far apart are the x's? You subtract them to figure that out. How far apart are the y's? You subtract them to figure it out. So if I quick wanted to remind you, if I wanted slope of a line, it's rise over run, right? Rise. So that would be change in y over change in x, because this is your rise. How much does it change up and down versus how much does it change left to right? You don't need that one. I'm just showing you in another spot where it could be. So learn that delta. Delta means change. Okay? All right. So I'll be using the second formula. Midpoint is another helpful tip or another helpful tool. The formula that you will need, midpoint is x sub 1 plus x sub 2 over 2. Is that a change or a sum? So it's not a delta, right? Not delta x because it's a sum of x, not a difference of x. So y sub 1 plus y sub 2 over 2. It's just average. Just find your endpoints, add them together, cut it in half. Find the midpoint. Okay? So there are the 2 formulas that come from linear equations that you'll be using. Standard equation of a circle. Here it comes. Looks like this. Quantity x minus h squared plus y minus k squared equals radius squared. Do our conditions for the circle exist? Do our coefficients of x and y the same? Yes? Are x's and y's both being raised to the second power? Yes? Are we adding them? Yes. So this will definitely graph a circle. What we need to know is what is the center. And when the equation is in this form, the center is at h, k. And r is the radius. So when you're given the equation of a circle in standard form, it tells you the center, it tells you the radius, which is nice because then you can plot it on a graph and off you go. Okay, so we're going to talk about that. An additional formula that I didn't put in your note page that you're probably going to want to have is the area of a circle, and the area of a circle is pi radius squared. Okay, so just squeeze that in there somewhere. And notice that the area of a circle contains radius squared. This is helpful. All right, ready? Okay, so you have a little bit of empty space under letter B in your note page. And I'm just going to connect some things for you. Number one, this important statement right here. To write the equation of a circle, you need two things. You have to have these two things, center and radius. Well, at this point in your math career, that's what you need. I could give you 3 points on the circle and I could have you find it too, but that's a pain and we're not doing that. Okay? All right. So those two things, center point and the radius. So this is what we call, excuse me, I'm getting a tickle in my throat, analytic geometry. Analytic geometry is geometry that happens on a coordinate plane. Regular geometry is just like if I were to give you a right triangle. What would I label this side if I was doing regular geometry? Okay? What would I label this side? And what would I label the hypotenuse? Okay, so that's geometry, right? And what formula do we know that goes really well with that? Pythagorean Theorem. A squared plus B squared equals C squared. Well, analytic geometry is just geometry that's happening on a graph. So the alphabet soup of regular geometry becomes the alphabet soup of analytic geometry, but there's a big connection between this right triangle that we just talked about and the formula for the standard form of the equation of a circle. So I'm going to derive that equation, that formula that I just gave you, x minus h quantity squared plus that one that we just did. So what I'm going to do is I'm going to put this on here. This is circle C. Circles are named by their center point, and the center point is C, so this is circle C. And notice that the center of circle C is HK. That's my center point. And point P out here at XY is a point that's on my circle. And all the points, if I take this radius and I start spinning, all these points are equidistant from the center, right? I could go radius this way, right? Or radius that way. I can go lots of ways. So if I drop in a vertical and a horizontal, because my changes in x's and my changes in y's, can you transfer this information to this picture? But this is the change in x or y, this vertical change. It's up and down, it's vertical. So is it changing my x coordinates or is it changing my y coordinates if I'm dropping? Y. So I'm starting at y, and if I want to find it, and I want to get to k, I subtract k. So that's the distance between this and this. It's y minus k. What's the distance here? Starting at my point, x minus, if I want to get from here to here, minus h, right? Because this is my x and this is my h. Those are both in the x coordinate position, right? Position 1. That's the horizontal. Okay, and this is what I call my radius. Do you agree? Yes? So this is the distance x minus h. This is the distance y minus k, and this is the distance radius. Could I consider this the Pythagorean theorem? Could I say x minus h quantity squared plus y minus k quantity squared equals radius squared? I mean, isn't that what happens over here? It's transferable. So this standard form of the equation is just a transfer of the Pythagorean theorem. They're the same thing. It's just a different alphabet soup, right? Okay, here we go. Problem number 1. A. This is the example of a circle. What we need in order to graph a circle is we need to know the center and we need to know the radius. So, what is the center of this circle? Okay, so let me back it up just a little bit. If I wanted the center of this circle to be at 0, 0, okay, if I change the equation, no shifts, its center would be at 0, 0. And by the way, this is my radius squared. So what's my radius? Oh, and you see a picture there. I have it graphed. I did not want to have that graph. Let me remove that. Okay, so this equation right here has a center at 0, 0. It doesn't have any shifts. It's centered right in the middle, and it has a radius of 4. It'll go out 4, up 4, left 4, down 4. Okay. This equation is the same circle, same size. It's just been shifted. Moved, the center is in a new location. So to find the center, we're looking for the number that I can put here that will zero this out. What will zero out this quantity? 2. And in this situation, y must I use to zero out this quantity? -1. So its center is at 2, -1. And its radius, this is my radius squared, its radius is 4. So we're going to take this circle that was originally centered at 0, 0, push it right 2 and down 1 and graph it. So I'm going to put a point right there. And then all I do to do my radius is I go off of that in the horizontal and in the vertical. Okay. And I'm going to grab out my compass because I have it. It's a nifty tool. But as long as you've got your radius there in the right spot, you can sketch it and it doesn't have to be perfect. Okay? I don't care if it's a wonky circle. As long as the center's in the right point and you've identified that the radius is 4. Okay? Got it? All right. Questions about that? Shifting right 2 will zero that out. Shifting down 1 will zero out that quantity. So that's moving the center. Right 2 and down 1. Okay, going over here to B. Does B have the conditions of a circle? Are the x and the y have the same coefficient? Are they raised to the second power? Am I adding them? No. That creates a hyperbola, which is not what we are doing today. So we just want you to pay really close attention to all those criteria that we investigated a little bit earlier. Okay? Questions about that before we move on? Okay, so now we're going to boogie through these examples. So here's your instructions. Guided practice. Use the information provided to write the standard form of the equation of each circle. Remember what I said. What do you need to write the equation of a circle? The center and the radius. So let's take a look at this information. I have a center at 5, 0 and a radius of the square root of 17. Do I have what I need? Yeah, so I just get my formula out. It's x minus h, which is 5, squared, plus y minus k squared equals radius squared. You think I'm going to accept it in that form? Or do you think you could do a little simplification for me? Absolutely. We want x minus 5 quantity squared plus y squared equals 17. Okay, so since there was no shift on the y, there's no need for those parentheses because it's not shifting up or down. But the conditions still exist. Same coefficient of your x and your y. They're both the second power and they're being added. It's a circle. Questions? Awesome. Moving on. Problem 2. Centers at 4, -2, and a point on the circle is 1, -3. Do I have right now the information that I need? I have the center but I don't have the radius. So there's a couple things I could do. I could use the distance formula because from the distance between the center and a point on the circle would be the radius, right? And if I'm not feeling comfortable with that, of course, I can go ahead and graph both of them, this being the center, this being a point on the circle. So it does like that. Pretend I did a good job. And this is the radius. So what's my change in y? What's my change in y, guys? How much did it change from here to here? How much did it change from here to here? So I could do radius is equal to the square root of my change in x, which was 3 squared, right? I'm doing that. I could also do that here. Look, I can just connect my x's. What's the distance between them? And then plus, and what's the distance between -2 and -3? Positive distance. 1. Right? Isn't that what would happen if we were using a Pythagorean theorem down here? 1 squared plus 3 squared equals r squared. Right? So my radius is equal to the square root of 10. And down here, if I do that math, I would do 1 squared plus 3 squared equals r squared. So 10 equals r squared. So r equals the square root of 10. There's the distance formula. Notice I did that in 3 ways. I drew a picture, I imagined my change from my picture, or I just found the distance between my x's and the distance between my y's and plugged them into the distance formula. Now, do I have the information I need? So it's x minus 4 plus y minus -2 quantity squared equals the square root of 10 squared. Absolutely. We're going to simplify it right now. Absolutely. And you probably could simplify it in your mind. Finishing it up, polishing it up. X minus 4 squared plus y plus 2 squared equals 10. And the equation has been written. I want to know if you have questions, because we're really zooming. Last one. Okay, so here I've given you an equation of a circle, but I want you to write the equation of a circle, this circle that's been translated 2 units left and 3 units up. What am I going to do? Yeah, let's do some math. What's the center of my original circle? What zeros this quantity out? What zeros this quantity out? So there's my center. And my radius, square root of 49. Okay, so I want to take this circle that right now is centered at -2, 1, and has a radius of 7, which I don't feel like drawing that. And I want to shift it, including its center, 2 units left and 3 units up. Couldn't I just shift this point 2 left and 3 up? Where am I? That's not 2 left, that's 3 left. 2 left and 3 up. Did I do better that time? Okay, where am I? Where's my new center? -4, 4. So that's one way you could do it. You could actually just plot the original center and then actually translate it and get your new center from the picture. I don't have a problem with you doing that at all. But could you see a way to get around the graph? If I want to shift this left 2, where's it going to move? Isn't it going to move left to -4? If I'm going to shift this up 3, where am I going to end up? It started at 1, it goes up 3. There's another way you could look at it. You're taking this x, because if you're shifting it left or right, you're shifting the x. That's the horizontal movement. and 3 units up. So you could actually just imagine that happening. And so let's write the equation of our new circle. X minus -4, quantity squared, that's your H, here's your K, plus y minus 4, quantity squared, equals radius squared. Well, I already had that in the original equation, right? That's radius squared. The radius didn't change. The circle just moved. Clean it up. That would be x plus 4 quantity squared plus y minus 4 quantity squared equals 49. And that would be the new circle. And of course, you could graph it and regraph it and really just tattoo it on your brain what's happening and prove it to yourself if that's what you need to do. I need to know if you have questions about this. Yes?
So, because it translated, with radius still stays same?
Yeah, because it's the whole circle is just being moved. It's not being expanded or constricted. Yeah, it's the same circle, so the radius won't change. The center just shifts. And when the center shifts, the radius shifts with it. Okay? Any other questions?